Hi, it's good to see everyone once again. I wanted to make sure I gave you a few comments on how to best make ketones. In the synthesis questions, I've gotten a lot of emails saying that you've had some difficulty figuring out how to start these synthesis questions. So one of the things I think would be best for you to help with is to say, okay, if I have this ketone here, so I have this carbon-oxygen double bond, what are all the ways you could use to make this compound? So thinking about what tools you have right now, you want to stop and think what possibilities there are. So the question you're asking yourself is not only what reagent do I need to put over this arrow, but what compound could I use to make that reagent? They're both questions you need to ask yourself in your synthesis question. There's multiple ways you know how to do this. So pause the video, see if you can figure out three different ways, and then come back. Hopefully you've actually paused the video. One way that you can do this, for example, is to take a secondary alcohol, like this, and then to oxidize that up. So the reagents that's needed to use to oxidize a secondary alcohol up to a ketone would be KMnO4. Also could be used is the chromium reagents. The Jones reagent was CrO3 and acid and water, or the Na2Cr2O7. But remember, KMnO4 is the easiest one to memorize. Other ways that you could do this, we know two other ways here. One would be to use ozonolysis. This is actually one that changes the number of carbons that are present, but you could have a carbon-carbon double bond here, and these H's could be any R group, and to relate those, and so you could use ozonolysis to do that. Remember, that's ozone followed by zinc and acetic acid, COOH, to achieve that. And there's actually one other method that we've had to where we could do this as well. If you think about this, so we can take an alcohol to a carbonyl, or a double bond, carbon-carbon double bond, so an alkene to a carbonyl. You've also learned how to do this using a triple bond. So you could either use this triple bond or actually this triple bond because of the example that I've drawn here, both of which using the addition of H2O to there. So we need water, H2SO4, and remember, if you're doing this reaction in the presence of an alkyne, you would need HgSO4 as well. And then this would actually make the enol, which then would tautomerize to the keto version. So by taking your compounds and figuring out where your target compound and figuring out where you might start with, that might be a good spot and a step in trying to decide what synthesis method to use.